Hello and welcome back to my channel. So the today's video is about the simple missions of part 2. If you have not watched the previous video, you please watch it. I will be providing the link in the I button. You can click on the I button and you can get access to the link of the previous video. So please watch that video and then continue to this video. So in the previous video, I have mentioned what is the efficiency of a machine. So what is efficiency? Efficiency is work output on load by work input by effort. So depending on that efficiency, we can classify machine as ideal machine and actual machine. Okay, so depending on that efficiency, we have classified ideal machine and actual machine. Now what is a ideal machine? First of all, let me tell, in ideal machine, efficiency is always 100% or 1. But in actual machine, efficiency will never be equal to 100%. It will always be less than 100% or less than 1. Now in the ideal machine, efficiency is equal to 100% or efficiency is equal to 1. That means in this ideal machine, work output on load by work input by effort is equal to 1. Since definition of efficiency is that one work output on load by work input by effort, that's why I have written here work output on load by work input by effort is equal to 1. It means what? Work output on load is equal to work input by effort. This is for ideal machine. On the other hand, on actual machine, what is efficiency? Efficiency is less than 1. Now what is the efficiency? The definition of efficiency is again work output on load by work input by effort less than 1. So from this step, what we can write, work output on load is less than work input by effort. Okay, so this is the difference between ideal machine and actual machine. On ideal machine, work output is equal to the work input, but on actual machine, work output is less than the work input. So now comes the mechanical advantage. What is mechanical advantage? The factor by which a machine multiplies the force applied, that is effort, is called the mechanical advantage of that machine. Now the formula of mechanical advantage is equal to load by effort. The mechanical advantage can have value less than 1, greater than 1, or is equal to 1. If the mechanical advantage of a machine is greater than 1, now what is the formula for mechanical advantage? It is load by effort. And here mechanical advantage is greater than 1 means load by effort is greater than 1. So here you can write load is greater than effort. So when this condition comes, that is mechanical advantage is greater than 1, this condition is called force multiplier. Why force multiplier? Because load is that force or load is that one which we get on the output, and effort is that one which we give our effort as input to that machine. So what we can write in this, output load is greater than input effort. That means what we can say, that our output is greater than our input. So whatever the input we have given, it is multiplied, and hence this condition is called force multiplier. Then next comes as the lever. What is a lever? A lever is a simple machine which we most commonly use in our daily life, and it is a rod which can turn about a fixed point called the fulcrum. If we consider this is as a rod and we consider that it is moving, or it moves about a, or we can say it turns about this fixed point. So this fixed point is called as the fulcrum, and on both the sides here we can get our load, and we can consider here as effort. So what is the spelling of fulcrum? Let me write here. It is the fulcrum, and that fulcrum is between the load and the effort. Now what comes? It is the principle of lever. In the principle of lever, it is stated. Now why it is stated, I don't know, because as definition is written as in the book, we have to learn it, and same as the principle, the whatever the principle is written, we have to follow it. So what is the principle of lever? It is written load multiplied by load arm is equal to effort multiplied by effort arm. Now what is load? This is the load L. Load means it is the force, And what is effort? Effort, it is the effort, it is also the force. Now what about load arm? What is the load arm? The distance between this end up to the fulcrum, it is the load arm. And what is the effort arm? It is the distance from the effort up to that fulcrum, it is the effort arm. So from this statement, what we can write is load by effort is equal to effort arm by load arm. Now how this statement, or how from this step I have written this step, if you understand what is an equation, you can simply write this. Or you don't know, if you don't know that what is simple equation is, then first of all learn what is the simple equation, then it is easy to understand how this step has come from this one to this one. So this is all about the principle of lever. Now for lever, what is the mechanical advantage? As from previous part of this video, we have learned what is mechanical advantage. What is mechanical advantage? We have mechanical advantage as load by effort. Load by effort. So from the principle of lever, what we have got, load by effort is effort arm by load arm. So we can simply write it here as effort arm by load arm. This is also mechanical advantage for lever. So for lever we have two conditions. For lever we have two conditions of mechanical advantage. One mechanical advantage is load by effort, which is in terms of force if we count, and second mechanical advantage is effort arm by load arm, which is the ratio of lengths. Effort arm, it is the ratio of lengths, and load by effort, it is the ratio of force. So for lever we have two mechanical advantages.